In this video, we're going to introduce machine learning as a lab. So first of all, let's review what is machine learning. So basically, machine learning is a mathematical model, and then it may have a bunch of parameters. Depends on how complex the model is. Some complex model may have like thousands of parameters. Some easy ones may only have like 2 or 3. So the whole idea of machine learning is we fit the model with a bunch of data. So kind of like find the optimal, the best fit parameter values, and then we are going to use that values as a trained model. So we can use that model to start to do the prediction. It could be a classification, could be some other regression, or it even can be unsupervised learning, like clustering. So those are the basic idea. And in this lab, what we're going to do is actually use the primary, one of the main package. It's called the scikit learning, scikit maybe. So what is this? Is a simple but efficient tool for predictive data analysis. And we have basically all the types. So we can do all of those. We can do classification, we can do regression, we can do clustering, we can do dimensionality reduction, model selection, and pre-processing, a lot more. So this is a completely free model. If you want to see that, you can actually study that, get started. So it will start to introduce how to use this one, but we are going to directly use our examples. We can directly get what we're working on, and there are actually a lot of them. So there are many examples too. If you want, you can see some of the examples maybe close to yours. Then you can take a further look. But here, what I'm going to do is just to do a few of the examples that are very similar to the examples that in official ones, but we use different data. So what are we using here is use some data that can be downloaded from the website. Like we mentioned at the beginning of this class, Python has a very strong community, so that's why we can get the benefits of those packages. We don't have to write them from scratch. So the goals of this chapters will be introduce the fundamental vocabulary and the concepts, and then introduce the scikit learn API and show some examples, and take a deep dive of details of several most important machine learning approaches. Basically there are several types of machine learning. So generally you can put all the machine learnings in 2 categories. One is called supervised learning. So basically means you are going to have 2 parts of data. One is for labeled. So human actually will start to label those data. So you place a label. Let's say this is a plastic, this is glass, this is a metal. So those are labels that you can actually read those data, and then you're going to put those data in 2 parts. One is for training to find the optimal parameters for the model. The other part is used to to actually test the data to evaluate the performance of the data. So in the future, when we have a similar type of data, we can use the trained model to directly do the prediction, like this item should be labeled like this, with a precision or confidence of probability, right? So in that way, we are doing some probability to put a certain item into a class, into a certain type. So that's called classification. The other one is a regression. So it's gonna predict continuous labels. This classification is predict labels as one or two discrete categories, like glass, plastic, metal. Those are not continuous. They are discrete classifications or discrete categories. Well, regression is like you're predicting something, like the sales price is gonna go with the time. That's a typical continuous labeling. And unsupervised learning is going to be the model. So we don't use humans to actually label the data. Instead, we just throw the data to the model, and then the model will be able to detect and identify the distinct groups in the data. And then that's for each data, then we can put a label, or they will put a label 1, 2, 3. So this is a clustering. The other one is called the dimensionality reduction. The models will actually detect and identify lower dimensional structures in higher dimensional structures. Let's say there is a 1,000 dimensional data, and you want to, because that's a lot of data, it needs a lot of calculation. Maybe we can use some models somehow, take some samples, and then we can keep the key features of those data. However, we don't have to calculate that much anymore. We can greatly reduce the complexity of the calculation. So that's called a dimensionality reduction. So all of them are, so those are kind of like rough classification. So let's start first with the SCI kit learning, ski kit, maybe scikit. So scikit is actually characterized by a clear, uniform, and streamlined API, and is very useful with the full completed online document. So it treated data as a table. Normally, is the basic table will be two-dimensional grade data, and this one we're going to, for example, I have there's a famous data set. It's called the iris. Iris is a flower. It's a kind of like a database, a set of data for a flower, for a plant. So we can use that. It's analysis by Ronald Fisher in 1976, and this data is public available, so we can use it as a study data. So what it says is you're going to have, so you can directly use SNS, which is in the Seaborn package, and you can show the head of the data. So it's basically have the length, width, petal length and width, and the species. So it's a typical flower. Okay, it's a flower. So in general, we can refer the number of rows of maxima of the matrix as samples, and we can the columns we call it features. So like earlier we said that we want to reduce a higher number of features into lower features basically means we're going to reduce the columns to a smaller columns, so but we don't lose the precision. So that's a idea. It's called the dimensionality reduction. So features basically means how many columns. Like in this example, we have 1, 2, 3, 4, 5 columns. So that means 5 features. So this is known as n features. So the feature matrix is actually we can use those matrix, use those features to representing the data. So it's normally in NumPy we use as NumPy array. In Pandas we use as a data frame. So we can put that the whole data becomes like for two-dimensional data. It will becomes n samples and n features. So you have sample and the feature, and that's perfect for data frame, right? Data frame has rows and columns. So next one is we can actually in this example we're going to create a inline plot of a certain data. We're still using the iris data, and we're going to plot the whole data as the sizes here, and the hue is spaces. So totally we have 3 spaces, right? And then we can use that, and different colors, different shape. You can tell that's this is like a cluster, and this is another cluster, and that's a third cluster. So like those, right? So those are examples based on what are the features we can plot the relation. So this is a very, very typical to find what's the relations among them. Okay, so to summarize the expected layout, the features, and the target values is visualized to the following diagram. So we have a feature matrix. We have feature matrix has n samples and n features. However, we can actually make a target vector as n samples. However, we just use one value to representing one vector to representing the whole feature matrix. And how do you give the values to this target vectors? That's the training. That's the whole point of machine learning. So this one is very, very important. Once you train the data well, you're gonna have a very good, very representing target vector. Okay. The basic API of the scikit or scikit are actually that following. So those are the basic steps. It's a standard step almost for all those models, no matter what it is. The first step is choose a class or of model by importing appropriate estimator class from the scikit learn. And the second step is choose model hyperparameters by initiating this class with desired values. And the third step is arrange data into a feature matrix and target vector following the discussion above. And then you're going to fit the model to your data by calling the function or the method fit on the model instance. And then the fifth step is apply the model to the new data. For the supervised learning, often we predicted the labels for unknown data using the predict method. For unsupervised learning, we often transform or infer properties of the data using transform or predict method. So let's go through the 5 steps one by one, and let's see how it's going to look like. So first of all, we're going to try supervised learning example. We can do the simplest data learning or machine learning is called linear regression. So basically, we have a lot of data is plot like this way. Can we define a linear formula that can doing this kind of prediction? So the data will be roughly on that line. So in this case, we're import a matplotlib dot pyplot as plt, and then we imported the numpy as np. So we've just randomly generate a bunch of random state as 42. So we just generate a bunch of random numbers, and then x will be the random number of 50 multiply 10, and then y will be actually a linear function. So it is actually 2 times x minus 1 plus the random number. So it's gonna be, so that's gonna be roughly it's actually when x is 0, it's gonna be negative 1 somewhere here. So it's going all the way up, going all the way up. Yeah, so this is negative 1, right? Starting from here, going all the way up here. So that's the data. So we have a scattered data x and y like this, and then this is just the data set. This is the data. We have the x and y now. So now let's try to choose a class of model. In this example, we're going to use linear regression, and this is actually preparation of the data. So we have roughly about 50 data, and then now we're going to choose a class of model. So the first step is you import that model into the project. Second one is choose model hyperparameters. So an important point is that a class of a model is not the same as the instance of a model. So once we decide to use our model, we can use some options options, and so there are some questions you get to answer. It's like, would we like to fit the offset? Would we like the model to be normalized? Would we like to process our features to add model flexibility? What degree of regularization would we like to use in our model? How many model components would we like to use? So these examples of important choice must be made once the model is selected. So you will see your data and then answer some of those questions. So in our case, we will do we will just simply make an object of our model. It's going to be linear regression, and we turn on the fit intercept as true, and this is going to be our model object of linear regression model. So once we have the model, then here we can specify what is our x and what is our y. So in this case, our x will be basically from the original x, we're going to slice it from the beginning to the pretty much the end, and then our shape for this one is 50 by 1. 50 by 1. So we're going to have 50 of the x, and then it's just a 1. It's like a vector. Then second one is we're going to fit our x and y. We're going to fix and the y. In this case, our x is actually a vector, y is also a vector, and eventually we're going to fit and train the parameters. And now we're going to find what's the coefficient. What's the coefficient? That means what is going to be our this coefficient. That's our coefficient. Because linear regression is basically it's ax plus b, right? Ax plus b. So our coefficient is going to be 2. So here with our model suggested that our coefficient is actually 1.977. So this will give us basically is like 2, right? Basically is like 2. So this 2, and then we have the intercept as negative 0.9. Take a look what we have here. We have pretty close. We have -1, right? Intercept is -1. Here is -0.9. So the two parameters actually representing the slope, and this is our slope. The coefficient is our slope, and the intercept of the simple linear fit data. So basically, we have is 1.97 x minus 0.9. So that's our curve. So our curve is going to be a little bit higher than the this one, right? So it's going to be in the middle. So that's how we do our linear program, and then we can, once we trained, we can actually predict the labels for unknown data. So for example, once the model is trained, we have the two parameters. We can do the predict. Now we generate a bunch of x's, and now we're going to do the x fit, and then y fit will be, I'm just send the x fit, and then use the model.predict, so we can actually predict a y's value. So y's value is going to be a vector as well. Now I can scatter the x and the y. So those are those random numbers, and then I can plot my x fit and y fit. So x fit and y fit will be roughly right here. So you will see they're pretty accurate. So this is a very simple and easy example. Hopefully everybody can understand this.